My name is Nikola, aka Socrates, and you're watching another episode of Singularity One-on-One.
Singularity.
Today, my guest is Vitalik Buterin. Hi Vitalik, it's fantastic to have you on the show.
Oh, great to be on here.
Super. So, Vitalik, can you please tell us what do you do and a little bit more about yourself for those of our viewers who may perhaps not be familiar with your work and you?
Yeah, so my main job right now is as the chief scientist of the Ethereum project. It's the thing that we'll be talking about today. I've been involved in that since pretty much late November last year. And aside from that, I've also done a whole bunch of different things in the Bitcoin and cryptocurrency space. I've been a co-founder of Bitcoin Magazine, involved in several different Bitcoin software libraries. So this whole space has sort of been my full-time job for pretty much the past 3 years now.
That's amazing. So you're actually one of the dinosaurs. 3 years in the Bitcoin space is like almost as long as I can think of.
Well, the real dinosaurs are like Nick Szabo and Hal Finney and so forth, who were around Bitcoin before Bitcoin even existed.
And of course, Satoshi.
Yeah. Well, supposedly Satoshi is Nick Szabo, but we'll see.
Yeah, I've actually been trying to get him on my show, but so far he hasn't been responding to my email request. I will keep trying though. Anyway, Vitalik, can you tell us a little bit more about Ethereum? What is Ethereum for those of us who may not be familiar with it?
So the idea behind Ethereum is basically that if you look at Bitcoin itself, when it was formed and created in 2009, was really two experiments at the same time. It was trying to test out two separate but very, very much new and untested technologies. So one of those was this idea of a completely decentralized currency. So it's this currency, this unit that exists only on the internet, but at the same time has this sort of cryptographically enforced digital scarcity. And the other experiment was this idea of using a blockchain in order to secure distributed consensus. So both of those two things are obviously needed in order for the other to exist. You need to have decentralized consensus in order to have a distributed currency. And as it turns out, you need to have a currency in order to have consensus because you have to provide economic incentives. But at the same time, like almost as soon as Bitcoin was created, there's been a lot of interest in this idea of, well, why don't we take the decentralized consensus and use it for other applications as well? So the basic problem that Bitcoin managed to solve that was stumping the whole digital currency space for about 30 years is this idea of the time stamping problem. So if you look at two different transactions, so let's say I have 50 Bitcoins, I send those 50 Bitcoins to Nikola, but at the same time I send those exact same 50 Bitcoins to some other friend. Then one of those two transactions will be able to make it through and the other won't. But the question is, how do you figure out which one it is? You have to figure out which one came earlier. And you can't just look at a sequence of bytes and figure out when that sequence of bytes was created. That's basically the time stamping problem. And the blockchain came up with the first solution. So the insight that people had was, well, wait a minute, this distributed time stamping, it's this actually really amazing technology that can be used for a lot more than just money. So you can use it, for example, for decentralized name registration, domain registration. So for example, if I register a domain like say Vitalik.ca, and then you want to register Vitalik.ca as well because you see, hey, you can impersonate me. Well, both of us submit our registrations, but only mine succeeds because mine came earlier. It's a first-to-file system. So any kind of application that benefits from this ability to tell when a certain message was sent is really something that could be improved using the blockchain technology. And so people started to think of, well, how can you create a platform that allows people to do more and more of these things using the same functionality? And there are different protocols with lots of different features piled onto each other, things like smart contracts, decentralized exchange, assets, name registration, and so forth. And the idea behind Ethereum is to take this general idea and make it maximally abstract. So instead of having a protocol with lots of features, what you have is a protocol with a built-in programming language, and then you can write whatever features you want on top. It's a sort of completely abstract, decentralized consensus system.
So basically, in other words, what you're saying is that what makes Ethereum unique and different from Bitcoin is the fact that it will be featureless, but it will be sort of like a layer, like an operating system, like a platform on top of which you can build any feature.
Exactly.
Okay, so let me just ask you here, why the name Ethereum of all the possible names? What's in the name?
Yeah, I actually came across it when I was browsing some online list of elements from science fiction. And the reason why I liked it is basically it's got the right connotations. It's got ether. It's this thing that's sort of up there in the clouds. Like originally, the word ether, like in ancient Greece, it would refer to this sort of basically the sky. But then in the 1900s, there was this idea of, well, if water waves travel through water and sound waves travel through air, what do light waves travel through? And people hypothesized that there was this medium in the universe through which light waves travel. It's the sort of thing that's invisible, but at the same time omnipresent. Mm-hmm. And that idea of this network that's completely in the background, and invisible, but at the same time is really sort of the backbone underpinning everything. That's basically what I wanted to capture.
So basically, Ethereum would be the medium in which all those potential apps will be created and sort of disseminated.
Exactly.
Fantastic. Vitalik, let me ask you to roll back the tape a little bit and tell us, how did you even get interested in Bitcoin in the first place, and why? Why did you get so captivated by it?
Mm-hmm. Yeah, so the first time I heard about Bitcoin is actually when my dad told me about it back in March 2011. I immediately discarded the idea. I thought, there's no way this thing's going to work. It has no intrinsic value. Then a few weeks after that, I heard about it from some online podcast again, and I thought, hey, why don't I actually try to get into this a little more? And of course, back then I had no money, so I figured, okay, I'll have to get some Bitcoins through some other means. So I started scouring the Bitcoin Talk forums for jobs. Eventually I found some guy who was basically starting a Bitcoin blog, and he was paying people to write articles for him. He was paying people 5 Bitcoins per article, which back then was $4. So that's first job I ever had. Started writing those articles. Paid me an average of about $1.50 an hour. Earns 20 Bitcoins with 4 articles. Spent 8.5 of them on a t-shirt. Earned some more. Eventually, actually, money ran out. And so what I actually managed to come up with is I managed to salvage the site and keep it running for a few months longer, basically by inventing this new business model where what we would do is I would write 2 articles every week, and then we would publish the first paragraph of each article on Bitcoin Talk, and we would publish a Bitcoin address. We would say, these articles are for ransom. If the community can together donate 2 Bitcoins to this address, then we will publish the rest of the article on the site. And it actually worked. So...
Wow, that's absolutely brilliant. That actually gives me ideas for my own blog. That's totally brilliant. And what happened next? Did you manage to sort of liberate and publish all of the articles you wrote this way?
Yep, they were all published. Yeah, that continued for a few months, and then eventually, of course, Bitcoin Magazine came along.
And what was the sort of the break point that beyond which you would have enough to publish the article?
We started off with something simple, like in the $10 to $30 range. But that's, I'm sure we could do much higher now just because the community is much larger and it's not just a bunch of people in their basements with 0.4 Bitcoin each.
Mm-hmm. Yeah, I should definitely give that a try for my own podcast, see if it helps. So what happened? You discovered Bitcoin. Were you a student at that time in computer science by any chance?
I was still in high school.
Oh, still in high school. Okay. Mm-hmm. And then?
Yeah. So then started Bitcoin Magazine with Mihai Alicia. First business ever had. Then that kept on happening. Eventually left high school and went to University of Waterloo to study computer science. So even though I dropped out, like the computer science program there was really good. Like there are people there of the caliber that actually win international math and programming contests. There's a lot of the content that was covered was like advanced computer science involving structures like binary trees, algorithms, compilers, interpreters. A lot of that went straight into the development of Ethereum, really. And so that kept on going for about 8 months, but at the same time, Bitcoin started growing stronger. And eventually in April, I was noticing that I was actually spending more time on Bitcoin stuff than on actual university stuff. And that's when I realized that it would really make sense for me to just go into the Bitcoin space full time.
And did you realize that was a very, very expensive t-shirt?
Back then, no.
I mean, with today's prices, what do you pay? 8.5 coins? That's what, 8 by 5? You know, that's $3,000-$4,000. Maybe more. I don't know if it's $400 or $500 today, but it's at least $4,000.
Yeah, $550 Canadian makes about $4,800 for the t-shirt.
Yeah, yeah. I was calculating in US. Anyway, that's one expensive t-shirt. So, what happened? You decided to drop out of college and focus entirely on Bitcoin?
Yeah, so when I dropped it, so the University of Waterloo actually has this thing called a co-op program where you sort of study and then work and study and work. And so initially I decided to do something a bit more moderate, which is to make my first co-op term working for Ripple in the US. Ripple being it's this company that's creating another sort of second generation version of Bitcoin. Unfortunately, a whole bunch of immigration visa stupidity happened, and after about a month, they gave up trying to get in. And so instead, I went to join Mihai's other startup in Spain, which is a decentralized marketplace, basically. So that's when I lived in this place. This is actually a story that's good all by itself. I basically lived in this abandoned factory for 2 months in this sort of anarchist cooperative.
In Spain?
Yeah.
Wow, what place? What city?
It's close to Barcelona. The factory is called Calafó. It was started by this guy named Enric Duran. He's sort of like the financial Robin Hood. What he did was back in 2008, he took out about 500,000 euros worth of deposits from a whole bunch of various European banks. And then he just defaulted on all the loans, never paid them back, and dumped all the money into these cooperatives. So that was my plunge into this other equally interesting side of the Bitcoin community. So then it just kept on going through different places, and eventually I stumbled upon some people in Israel working on this cryptocurrency 2.0 idea. So back then, covered coins and Mastercoin were pretty popular, and those sort of seeds were really where the idea for Ethereum finally came from.
So, but let me ask you this. Did you tell your parents before you dropped out or after the fact?
So when I gave up on Ripple and I decided to go to Spain instead, it was after the fact.
So you kind of told them, look, I've done this already. I'm not going to school. I'm going to Spain.
Pretty much, yeah.
And what did they say about that?
They were quite happy about it, actually.
They were?
Yeah.
Interesting. That's very good. I don't think many kids get support from their parents like that in a situation like this, especially. Because, I mean, there's almost an endless supply of skeptics on Bitcoin, right? So it's really impressive to me that your parents would support you to jump into the unknown of Bitcoin rather than going into the sort of secure place of university and studying computer science.
Yeah, well, my dad's actually very much into all these different sort of radical ideas himself, so it's Bitcoin's right up his alley too. That's
fantastic. And plus, you can blame it on him. You can say, well, you were the one who first told me about Bitcoin, right?
Yep.
That can help. Anyway, Vitalik, tell us a little bit more about what's your biggest dream? What's your final goal? Let's just think that anything is possible for a moment and you can accomplish anything you can set your mind to. How's that look like?
Yeah, well, I mean, my personal philosophy has been not to set any goals with a time frame longer than about 2 months. It seems to work out pretty well so far. But if we can dream, I mean, there's a whole bunch of different things that I've always been interested in for a while. Things like online education, decentralized mesh networking, marketplaces, reputation systems, create this really sort of take the potential of the internet and sort of push it forward to its logical conclusion. That's been something that I've been interested in for really at least half a decade now.
What's the logical conclusion of the internet?
I don't know. I mean, I can tell what the directions are.
Well, so give us a hint. What are the directions?
Already named a few. You know, it's mesh networking. I think it's bound to happen eventually. So the idea behind that is interesting all by itself. Basically, it's right now you just have these sort of few centralized companies that are responsible for routing internet traffic. But what if you have a system where it's a mesh network, anyone can participate as in being sort of an intermediary node between you and the server, and the idea is that it's a market. So if I can just turn on my cell phone and I might route traffic through between one person and another person, I could earn a micropayment for that. And at the same time, you know, it scales up. So for something like Toronto to Sydney in Australia, obviously cell phones aren't going to cut it because you're going to need like 20,000 hops. But what you could have is you could have one company whose sole purpose is to maintain an undersea cable between Vancouver and Sydney and charge per megabyte for traffic routing through it. And you would have a protocol that just automatically looks for these kinds of cables and always just picks the cheapest and fastest path to go through. So that's just one of these ideas, all of these different ways that we can sort of maximally improve efficiency to the point where all of the various different bloat and infrastructure and complexity surrounding the internet today basically just all sort of disappears. It gets subsumed.
Now, let's go back and talk a little bit more about the differences between Bitcoin and Ethereum.
Sure.
One of the major ones, of course, is the fact that Ethereum is designed to be Turing complete. Talk to us a little bit what that means and why, for example, Satoshi decided not to make Bitcoin Turing complete.
Yeah, people love talking about Turing completeness, but as it turns out, Turing completeness is actually not really all that relevant. So there's actually several different differences between the way Ethereum works and the way Bitcoin works. And it's not just like, oh, we took Bitcoin and we added this magic Turing completeness opcode. That's not at all what we did. It's sort of a completely different architecture. So in Bitcoin, a script in Bitcoin is basically, it's a program that takes in an input and it outputs either 0 or 1. So one program might be verify cryptographic signature. And if it's 0, that means you can't spend the money. If it means 1, then you can spend the money and you can spend it for any purpose. So scripts have no way of allowing outputs for some purposes, but not other purposes. Then there's also the fact that there's no concept of internal state. A transaction in Bitcoin is either spent or it's unspent. You can't have like a multi-stage financial contract or a contract that includes its own database. So that is actually really the most important detail. So in Ethereum, it's a different model. Instead of having these coins that have scripts and scripts sort of unlock the funds, you have this idea of contracts where contracts contain a certain amount of funds, and the idea is that those contracts have programs inside of them, and those programs can send off whatever funds they need to in whatever quantities desired to whatever addresses. So you have pretty much total freedom. It's you can set up a contract where that contract is only allowed to withdraw to this particular set of addresses, or only allowed to withdraw up to a maximum of $100 a day, or even a contract that maintains some set of internal owners where that set can change over time. So it's actually all of those different benefits that really make Ethereum so powerful. So given that, of course, the other question is, well, why do we bother with Turing completeness if Turing completeness is so dangerous and it's so unnecessary? And the answer is that actually making Ethereum non-Turing complete would have been almost as dangerous. It's that because of the architectural decisions that we made and we basically had to make, like, once again, because it's this idea that in Ethereum we're calling the first class citizen property, where basically a contract can do anything that an external actor can. So that's because of that. It's a fundamental feature, but because of that, you have this exponential blow-up problem where what if you make one contract that calls another contract twice, and that contract calls a third contract twice, and so forth. So even if you don't allow computation that has loops, which is basically what Turing completeness means, you still run into pretty much exactly the same problem. So the answer is basically it doesn't matter too much either way, and we have a good mechanism for regulating Turing completeness, which is transaction fees. It works. So it's just the simplest way to go.
What would be those transaction fees in terms of, I don't know, value?
Yeah, so transaction fees in Ethereum, I suppose the more accurate name would actually be computation fees. The idea is that basically you have to pay a fee per computational step.
Okay, and how are you going to calculate the proper level of a fee? Is it a percentage point? Is it like a fraction? Is it like a Satoshi, or what is it?
So the idea is that it's an amount per computational step. So it's not really a percentage because the fee system doesn't even care about the value that you're sending. You could even be sending 0 and it would still charge the same fee. So there's sort of two separate questions, which is, number one, how do you measure computational fees between the various different operations? And for that, we have various different operation costs for some of the more expensive ones and just a minimal cost of 1 for things like add and subtract. And then the second question is, how do you set the base fee in the first place? So that's a hard problem. It's something that Bitcoin's solution, in my opinion, is completely and totally inadequate. So we have a system that's basically a combination of a market-based approach and a floating hard cap that basically ensures that the fee roughly approximates the actual cost of carrying out that computation across the network.
So there's no leftover value. It's all basically the cost of computation is the fee itself. There's nothing left over between those two values.
Well, I'm sure there will be something left over.
And what happens with that? Where does that go?
Yeah, so the fees go to the miners. So miners pay costs, so they get the difference as profit.
Okay, so perhaps this is the time now to talk a little bit about what's the difference between Ethereum and Ether.
Okay. Yeah, so Ethereum is the platform, and Ether is what's basically the currency, or we're calling the cryptographic oil of the platform. So it's this thing that you need to actually pay the transaction fees. So there's going to be probably lots of different types of currencies on top of Ethereum. I'm sure we'll have Ether, then we'll have various different centralized currencies for particular communities.
The Singularity coin?
Sure, Singularity coin. I'm sure people will come up with a version of Dogecoin. People will come up with a Bitcoin sidechain. There's lots of different ideas with what you can do. And the idea is that Ether is sort of like this base layer asset that's just used for basically regulating and mediating the computation underlying all these other systems.
And let's say that, for example, I want to launch my own Singularity coin on on Ethereum. How would I do that? And how expensive would it be? Or
yeah, so the general way that you would launch any kind of platform, product, service, whatever on Ethereum is basically by making what we're calling a DApp, decentralized application. So a DApp consists of an interface. So basically some nice, pretty JavaScript or Qt, and also a contract. So what a contract is in Ethereum is basically it's a piece of Ethereum code. So we have a programming language called Serpent. It's basically like Python that you can use to actually write the contracts, and they get compiled into this sort of low-level machine-like language. And then you would put that code into a transaction, push the transaction to the blockchain. And then once that happens, the contract will have an address. And then if somebody else wants to interact with that contract, then they'll be able to just send messages to that particular address. Yeah.
Now, let me ask you about, let's say, the top other 3 or 4 apps other than currency. What would be the most interesting ones?
Sure. So the way I generally classify Ethereum applications is in 3 categories. So one category is financial, which involves either currencies or better ways of managing your currency. So the better ways of managing your currency would include either various different things like financial derivatives hedging or things like escrow. So for basically ensuring either consumer protection or just personal security. So one of the ideas that we always float around is, well, what if I want to store my money in such a way that it's I use some kind of bank as sort of a cosigner. So even if my private key gets stolen, nothing bad happens. But at the same time, control the bank and don't give the bank all the power. So that's something that Bitcoin can do to some extent. That's something we can do better. Mm-hmm. The second category is semi-financial. So semi-financial is things like decentralized Dropbox. It's something we talk about a lot. Basically, the idea is you can have an Ethereum contract that can request cryptographic proofs that you're storing a particular file, and if you are, then it can give you a micropayment. So you basically have a contract and you upload a big file, and then the contract just automatically rewards people for storing the file on a per hour per gigabyte basis.
Basically, I'm renting out my hard drive space.
Exactly.
Okay.
And there's it's a lot harder, but there are also ways to rent out computational time as well. Mm-hmm. Theoretically, even bandwidth. So the idea is that, you know, if you've got a computer, your computer really has like 4 miners in it at the same time. It's got a miner for, you can mine Ethereum itself, then you can do some more mining with your CPU by running one of these computation for hire projects. Then you can mine a bit more with your hard drive, and then finally you can mine a bit more and participate in the mesh network with your wireless router. So that general category, I would say, is what I would call semi-financial. And there's a lot of very interesting ideas in the semi-financial, and especially in the micropayment space. Mm-hmm. Especially if you get into sort of the bigger picture, things like road tolls, for example. You can imagine if you have a sort of perfect market-based road toll system that would automatically charge you more for driving at rush hour towards downtown and a bit less if you were driving in the middle of the night somewhere far away and so forth. Mm-hmm. You'd basically be able to replace half of urban planning with this market-based system that just automatically aligns incentives for people to do exactly the right thing. Then there's just general resource allocation problem issues and so forth. Then the final category is, of course, the non-financial. So non-financial basically means things like decentralized governance. So people have been talking a lot about how do you run a non-profit organization or a for-profit organization like purely on the blockchain. So we've been using terms like decentralized organization, decentralized autonomous corporation or organization. So this idea that all an organization really is people with a set of resources and mediated by a set of rules. And what if you have a set of rules enforced very efficiently and cheaply by the blockchain? And together with that, there's, of course, decentralized voting. And finally, there's also these sort of other first-to-file systems that have nothing to do with money at all, which would be reputation systems. We've talked about domain registration, name registration in general. So, for example, if I wanted to make a decentralized Twitter, one of the challenges is, well, okay, you know, on the normal Twitter, we all have handles. I'm at Vitalik Buterin. I'm sure you might be something else and so forth. Singularity blog, perfect. Yeah. So that name database is stored on Twitter servers. If you want a decentralized Twitter, then guess what? You need a decentralized server to store name registrations. And that's what blockchains are extremely good for. And then we've got reputation systems, credential systems, social networks, and so forth. Mm-hmm. Yeah.
That's brilliant. So let me try and push you a little bit more on each of those points and see how far we go. Mm-hmm. So let's start with, let's say, decentralized Dropbox. Mm-hmm. Now, help me here to figure out how it's actually going to work in practice, because let's say a guy like me, I have probably about 1 terabyte worth of backup stuff on my computer. Now, one of the reasons why I'm using local backup storage at home rather than back it up on Dropbox is bandwidth, right? Imagine having to back up 1 terabyte worth of data. Rogers is going to basically overcharge me to the end of the world for so much data transfer. So that's one issue. The other issue is also that I foresee is, so one is the bandwidth clogging with, let's say you have 10 decentralized nodes that are sort of syncing in among them. Wouldn't that gobble out all the possible bandwidth? And then on top of it, you have the actual size of the database, right? In my case, it's 1 terabyte. Young kids nowadays have videos, large pictures, MP3s, movies, all kinds of large files. How are we going to overcome these two issues?
So one of the major important points is that it's not like we're going to be storing your 1 terabyte on the blockchain. It's a very common misconception, but that would cost you something like $20 million.
Exactly.
So the right way to do
Just for Rogers.
Yeah. Well, yeah, Rogers would charge $4 million. The transaction fees for the blockchain would be another 20. So the right way to do it is it's basically upload the file exactly the same way you would upload a file over BitTorrent now. So that's basically that's one approach. Or another approach is to actually find a few dozen specific nodes and give them each a certain piece of the file. So there's a set of algorithms called secret sharing algorithms that basically let you take a big file and
break it apart.
Break it up into pieces. So let's say, here's the trick. You take, say, a 1 gigabyte file. You split it up into 30 pieces of 50 megabytes each. So notice 30, not 20.
But then it's not really decentralized, because if one of those 30 pieces is dead, I can't have my file.
See, that's the point of the secret sharing algorithm. I said 30, not 20. 30 times 50 is 1,500 and not 1,000. So the idea is this algorithm, it automatically sort of builds in optimal redundancy. So you can take any 20 of those 30 pieces and you can get the original file back.
Ah, that's cool. That works, yeah.
Exactly.
Because my concern is, as you know, as I said, but you already addressed it. Brilliant. Okay, so let's talk a little bit more about the sort of the micropayment option, right? So how would you address those people who don't have Bitcoin to pay for road tolls, for example?
Yeah.
Because one of the issues obviously here is equality or equity. I mean, some people have already accumulated enormous amounts of Bitcoin. Actually, one of the reasons why science fiction writer Charlie Stross says that Bitcoin should burn in hell and would never work is that it has a terrible Gini index. That's in terms of its equity between people who own Bitcoins. Right? So it's actually worse disseminated than, let's say, any totalitarian country in sub-Saharan Africa. Right? And it's getting worse according to him. So the idea is basically if people don't have Bitcoins to pay for road tolls, how are they going to do it?
Yeah. So the important thing about Ethereum specifically is that, once again, we're not a currency, we're a platform. You can use whatever currency you want. So assuming this kind of road toll application is going to actually go mainstream, you would assume that whatever government would perhaps either issue their own sort of token system, and they might even decide to say give every person 20,000 tokens for free. And so the idea is that you would only actually need to end up paying if you're an above average user, and if you're a below average user, you can even earn a bit of money from the system. So it's basically, you can plug in whatever currency you want. You could potentially use some kind of blockchain-based dollar token. You could have Bitcoins, Ether, or euros, and whatever you want.
My concern is also for those people who are totally technologically sort of Luddites.
Yeah.
Let's say you're Amish. You have your horse and your buggy, and you're riding on the same roads that we're driving our cars. How are the Amish going to pay for the road toll if they don't even have a cell phone? They can't even make micropayment, right? So there are going to be a certain percentage of society who are never going to adopt any technology, right? Whether you're homeless, whether you're Amish, whether for some other reason.
Yeah, I mean, it's that's, I think, one of the biggest challenges with phasing in technology in general. It's basically the infrastructure problem, and I think a lot of the stuff we're actually probably going to see adopted pretty much in the third world first, and in more developed countries later on, just because they haven't had any existing technology that they're used to, so they can leapfrog over immediately to the new stuff. So yeah, there's always going to have to be some kind of mechanism for transitioning over, some kind of alternate solution for people who haven't moved over yet. It's I'm optimistic that we can find a way around that.
Yeah, because I think the devil is in the details, and the implementation there can actually make or break it, the success, right? Because if it's not implemented right, it could totally lead to failure, and if it's implemented right, it will be absolutely revolutionary, obviously. Now, talk to me a little bit more about the sort of decentralized app ecosystem, because I think that's a very important feature. How is that going to look like? What is it? What its main value proposition?
Right. So the idea is that right now we've done quite a lot of work on building the Ethereum protocol and building the Ethereum clients. But in order for Ethereum to actually be useful, you also need to have a large number of applications. So this is just one of the other ways that we're addressing the problem of, well, most people aren't too technical to be able to use something as advanced as Ethereum. And the answer is, well, they don't have to. Most people aren't technically advanced enough to use JavaScript, and yet they're still benefiting from it. So it's what we're trying to set up is we're trying to set up this ecosystem of basically apps, where we're calling them dApps, where each dApp is a combination of whatever contracts and an interface. And the idea is to take something like decentralized Dropbox or something like this name registration idea or decentralized currency and turn it into just an application that's maximally easy to use, just point and click interface, looks just like any other currency. And so what we want to set up is basically have what's like the Android of cryptocurrency. So in the Bitcoin space, the Bitcoin client and the Bitcoin wallet are synonyms. In Ethereum, that's completely not true. In Ethereum, the Ethereum client is more like Android, and the Ethereum wallet is more like one of the apps on top of Android. So in order for the whole ecosystem to work, we need to build the Android. We also need to build the equivalent of the Google Play Store. We'd also ideally, we like to eat our own dog food. We want to have the reputation system and the consumer protection systems for all these different app ecosystems, also based on the exact same technology that we're trying to develop. So that's something that we're really going to be pushing forward over time, especially once the client's implementation begins to solidify.
Let me ask you a little bit back again on the database issue. Now, I know that it seems to me at least one of the reasons why Bitcoin is being implemented and spread so easy is because the size of the blockchain, the database, is tiny right now, right? How is the Ethereum database size going to compare? Because apparently it seems to me as an ignorant software person that it would have to be much bigger, probably an order of magnitude, if not more, to be able to accommodate a whole platform that's Turing complete.
So the interesting thing is that in some ways Ethereum is less efficient, in some ways it's actually more efficient. So, for example, two of the architecture decisions that we made with Ethereum as opposed to Bitcoin is that Bitcoin is based on this concept of unspent transaction outputs, UTXO. The simplest way to think of it as being coins. Basically, the Bitcoin database is a database that tells you here are all the coins, and here's the denomination and the owner of each, or the script that owns each particular coin. And so, for myself personally, I would probably have like at least a few hundred of these coins of various denominations, from some number of BTC to like 6,000 Satoshis. In Ethereum, our approach is account-based, so you have one account and you just store a balance. So no matter whether you're just some new user that got one transaction, or whether you're Mt. Gox and you got like 20,000 transactions, one account, it's like 100 bytes. So the other thing is that...
You can fit all that in 100 bytes?
Well, in Bitcoin you can't, because Bitcoin's got a whole bunch of coins. In Ethereum, it's basically, you've got the account, then you've got the balance of the account, and that's basically all you care about.
And where's the rest of it? Where's the actual coins? If
they
you just have the balance.
Yeah, it's the actual coins don't exist. It's just like a bank database. A bank database, it's like a table. George 45, Mary 2000, Bob 1500, and so forth.
Okay, but my understanding was that you do have like actual coins that you transfer, right? So that's the coding thing from Bitcoin, from Satoshi. That's one of his original contributions.
Yeah, so Satoshi's Bitcoin architecture was definitely dependent on this idea of, well, we have coins, and in order to create a transaction, you have to spend existing coins and create new coins. That's an architectural choice that he made. It's not a necessary one. It's only one of the two ways to do it, right? Because the fundamental idea behind Bitcoin is that it's a consensus system that's backing up what's basically a state transition system. So the consensus system tells you what transactions happened in what order, and then you have the state transition system, which is, well, if you have this set of existing coins, it'll tell you whether this transaction is valid, and if it is, then what coins to take out and what coins to add in. So in our system, it's actually more traditional. We're basically saying, here are all of the accounts, and what transactions do is a transaction subtracts money from one account and adds money to another account.
And how do you avoid the copying issue?
Yeah, well, it's the rule is simple. So there's a database which maintains how much money each account has, and then the rule is that, let's say I have 50 Ether in my account. I publish 2 transactions. One transaction sends 40 Ether to you, another transaction sends 40 Ether to my friend. So publish both of them. Suppose that the transaction to you comes first. That transaction gets applied, and let's say before that you had 200 Ether. So then the database gets updated. It goes from 50 me to 200 U to 10 me, 240 U. And then that's the new state of the system. Then the second transaction comes along. Then the miner tries to process the transaction and notices, oh, this account only has 10 Ether left. It's trying to send 40 Ether. Not enough money. And it just returns an error. It's exactly like a banking database.
And if you return an error, do you charge a fee for that computation?
It's actually somewhat complicated because there are
because it takes some resources to calculate that, right?
Actually, in that particular case, yes, you do. So yes, you as the sender of the transaction do have to pay the fee, but the effect gets reverted.
What do you mean the effect gets reverted?
So basically, the transfer of 40 Ether never happens, basically. So the other point there is that if you have let's say you send a transaction into a contract, but you only pay for 10,000 computational steps.
Yeah.
But then the contract execution suddenly becomes a lot bigger than anyone expected and starts taking up more than 10,000 computational steps. Then as soon as you hit the 10,000 mark, all those computational steps, if they had an effect on the system, the effect gets reverted, it gets taken back to the start, but the fee gets paid anyway.
Yeah, but if the fee gets paid anyway, let's say I misjudge and calculate the steps necessary. Yeah. Does that mean I can kind of empty out my account in fees that could gobble out all my balance without actually accomplishing?
No, so the one point there is that you do have to explicitly consent to every reduction in your balance, right? So if you send a transaction where you pay for 10,000 computational steps, there's no way you're going to lose more than 10,000. And the other thing is that the general strategy that I expect clients will take is that they'll sort of run the transaction just simulated locally. They'll see how many steps it'll take, and then they'll send a transaction with that plus a safety margin. Say something like 2x or 4x. So the chance that it'll fail is really low, and even if it does, then you just send it again.
How secure is that system, Vitalik?
It's against what kind of attacks?
Well, let me give you an example. I actually interviewed Jordi Rose, who is the Chief Technology Officer of D-Wave quantum computers. And we talked to him a lot about, because obviously encryption is key feature of this whole platform. And we talked to him about breaking code with their computers. And Jordi's answer to this was basically, we're not interested in that space. We're not going to use our machines for any of that space. But my response would be like, yeah, but somebody will, right? And once you sell that computer to a third party, you have no control pretty much of how it's being used. So let's say you have and there's, I think, 3 quantum machines up to now.
Okay,
Would this be secure in terms of breaking the codes in it with a powerful machine like that?
There's a lot of misinformation out there around quantum computers. So first of all, D-Wave's quantum computers, they're adiabatic quantum computers. Adiabatic quantum computing is basically this clever strategy where you try and solve computational problems by reformulating them into energy optimization problems. So basically you align some particles in such a way that the lower the energy state of those particles is, then the better a solution to a particular problem is. So and then the idea is that you would use, the particles themselves would use quantum computing tricks to sort of magically enter the lowest energy state that they can. So an important point is that that kind of quantum computing, it's not really real quantum computing in the sense that a lot of people think about, right? There's actually only a very limited class of problems in which it's better than conventional computers at. Generally, when people talk about quantum computers, they talk about these things like Shor's algorithm and Grover's algorithm that can solve problems like factoring much more easily to the point where RSA and ECC pretty much become trivial.
Obsolete.
Yeah. So those kinds of like actually powerful quantum computers, they're still quite far away. Yeah. Like the most powerful quantum computer so far of the sort that can do Shor's algorithm just used it to factor the number 21. So we're still in the 5-bit days here.
I totally agree, but my concern is this, right? If Bitcoin is here to stay, it will be here 10 or 20 or 30 years from now, and the same applies to Ethereum. And those algorithms would be locked. Would they not be locked? Would they be able to evolve? And my concern is that 15 years down the road, instead of mining with a desktop, some smart and rich fellow may start mining with a quantum machine better than what we have currently today, and then we'll be able to sort of cheat or break the system, break the cryptos.
Yeah, so the one thing we're trying to do with Ethereum in the long term is actually try to remove this notion of having certain intrinsic algorithms. So right now, every account is protected by elliptic curve DSA, but in the future, we want people to be able to use the exact same contract mechanism and basically just choose whatever crypto they want. So there's an interesting kind of digital signature. It's called a Lamport signature that you can use to basically sign messages just like ECDSA, except it's quantum proof. So the two big reasons why not everybody's using that yet is, first of all, it's less efficient. So a Lamport signature for 160 bits of security takes up 800 bytes as opposed to 64 bytes. And the other thing is that it's a one-time signature. So there is a construction where you can turn that from one-time signature into like a 20,000 times signature, but even still it's limited. So there are definitely ways to do it, and we are actually looking right now at how try to integrate those different signature types as options. So it's definitely something we're thinking of.
Yeah, brilliant. And based on what you're telling me, I'm optimistic that you're thinking about that, and especially if the algorithms are not locked but can evolve over time. That's fantastic. Vitalik, tell me, what, in your opinion, is the biggest misconception about either Bitcoin or Ethereum or both that you want to really dispel? Something that's really probably annoying or you get to encounter way too often for your liking.
Well, the Turing completeness one is actually pretty important. I would say the bigger one just for average people is that Ethereum is not a currency. So Bitcoin is a currency, but Ethereum, it's this abstract platform that lets you do pretty much anything that you want. Right, so a lot of the time people like to criticize Bitcoin for things like deflation, fixed supply, certain particular aspects of its economics, or even the idea of having a non-government-backed currency and so forth. Whereas with Ethereum, like all of that is really quite separate. So, like as I was saying, there is Ether, but at the same time, there's the opportunity to have pretty much any kind of currency on top of Ethereum.
Singularity coin, yeah. We're launching it soon.
Exactly. Singularity coin on top of Ethereum if you want.
Brilliant.
Yeah.
Now, tell me, where do you see Ether in, let's say, or Ethereum, in 12 months and in 5 years from now?
Yeah. 12 months, I would say. So the first 6 months are going to be heavily dedicated to getting Ethereum actually to the point where we're ready to launch the main blockchain, get Ethereum 1.0 out. Once that happens, the focus is going to heavily shift pretty much entirely on the space of applications. So I've already talked about some of the different sort of infrastructure that we need in order for Ethereum to really work. Things like name registration, reputation systems, security, Also, data feeds for financial contracts are very important. So all these different ecosystem details that can make the ecosystem so much better. That's something that we'll be probably working on all the way through 2015. At the same time, another important point is that, Ethereum 1.0 is not the end. We've got quite a lot of good context in cryptography, and we are probably almost certainly going to release Ethereum 2.0 sometime around 2016 or so, which will hopefully have much more advanced cryptography protocols that will really solve the scalability issue to a much greater extent. Because scalability, we're doing all that we can, but at the same time, there's this fundamental issue that every node has to process every transaction. And for 2.0, we're going to see if we can break that.
And what if it becomes way too popular and there's way too many people using it beforehand? Wouldn't you run into that problem faster than you expect?
So the nice thing is that Ethereum, even 1.0, it sort of gracefully decays. So there's this concept of a light client where you can use the blockchain securely without having a full node. And that's something you can do with Bitcoin, but it's something that we're going to be very specifically, explicitly supporting in Ethereum. So how to basically make the currency still fully secure, even if there might be only like 100 full nodes running in the network on big servers. The idea is that as long as even one of these large server nodes is honest, it can sort of act as a watchdog, and it can point out where the errors and any sort of fallacious blocks are, and all the light clients will easily be able to find out.
Because my concern is what happens in the moment where you have millions of nodes.
Yeah.
Would we gobble out the internet, the bandwidth, everything, just trying to sync between those nodes?
The thing is that it's
let's say 100 million nodes.
Yeah, it's a fundamentally economic problem, right? If there are 100 million nodes and there's 100 billion transactions on each node, then most of the nodes are not going to be able to afford to keep running, and they're going to have to switch to light clients.
Precisely my point, yeah.
Yeah, so somewhere in between everyone running a full node and a combination of full nodes and light clients is where probably the balance is going to be. And that's probably the best we can do, at least until the point where Ethereum 2.0 technology really becomes ready.
Yeah. The good thing is we don't have to solve the hardest problems at the beginning, right?
Yeah.
But only once we get there. So, Vitalik, tell me, let's say many people by now might be wondering, how do I get involved in Ethereum? How do I buy into Ethereum, or how do I get ethers? When do you guys launch, and how can people like me or anyone interested become a part of it?
Yeah, so if you want to join Ethereum, the simplest approach is really just start contributing. We have repositories for code if you're interested in programming. It's open source. You can submit patches just like any other project. That's actually really how most of our current team came in. Then if there's something else that you want to do, then you just contact any of us. We're quite public, spend a lot of time on the Reddit and the forums. If you want to be a partner, if we have a lot of opportunities in the ecosystem. We've been talking about things like financial markets, some of these ideas around micropayments. A lot of them we're definitely not going to be able to do ourselves, and we really want to work with other organizations who can help us, that have the experience and the connections and the knowledge to be able to actually implement these kinds of systems in reality. So if you think that you have an opportunity where we can work together on that front, contact us. We're available by email.
When do you launch?
Yeah, so when we launch, the next big milestone is the Ether sale. So this is when we're basically going to be selling the first few units of Ether. It's basically unlimited at 1,000 Ether for 1 Bitcoin, or 2,000 if you buy in early. And that will be the way to buy Ether at this point. And then once the Ethereum itself launches, of course, you'll be able to get more Ether either by buying it off the market or by mining. So mining is something that, unlike Bitcoin, Ethereum is going to keep on releasing new units of Ether forever at a fixed rate. And
but when would people be able to buy?
So when the sale, at this point we are looking at something like a week or two. It basically depends on some final legal and computer security issues. Yeah, and the Ethereum blockchain itself, we are hoping for, we are setting ourselves the target of the second half of the year.
Now, let me ask you a little bit about that exchange rate, because that's a crucial part of that sale. You said 2,000 for one Bitcoin if you get in early, because obviously there's a higher risk, and then 1,000 later. But that's kind of like fixed exchange rate. Who makes that decision, and why at that level? Why not 10,000, for example? Why not 100? Why not 10? Why not one-on-one?
Well, the thing is, it doesn't really matter, because
but if it does, doesn't it?
If it was 2 million Ether for a Bitcoin, then there would be 1,000 times as much Ether, and so it would be 1,000, each unit of Ether would be 1,000 times less valuable, and it would be equivalent. So it's basically just a matter of sort of how much do we want each individual unit to be worth. And at this point, we feel that having each unit of Ether start off by being worth $800 is just a bit too inconvenient and expensive. So right now, we're basically targeting something like 25 cents, which is what 2,000 Ether for a Bitcoin gives you.
Okay, but that's part of the equation. So that's your target of what you want it to be worth, but it doesn't make it worth so.
Right.
Right? So it's one thing to have, I want it to be worth that much. It's another thing to be actually worth that much.
Yeah, so the idea here is that in a normal fixed supply sale, the organization chooses the supply and the market determines the price.
Exactly.
Here, we're determining the price and the market determines the supply. So
what you're saying is if people think it's too expensive, they wouldn't buy it.
Yeah.
I see.
Or rather, if people think it's too expensive, then fewer people would buy it.
Yeah, and the price would naturally fluctuate down, hopefully.
Yeah. So the idea is that if for some reason everyone thought that there is no point in buying Ether is way too expensive, and let's say only $400 got pushed into the sale, then you might see, oh hey, I can throw in $100 and I'll get 20% of all Ether in existence, and that'll be a very good deal for you. And somewhere in between that and a much higher number, it would be the balance.
Yeah. But that's one of the scenarios where we run out into those Gini distribution issues, right? Because if one person becomes too big in the beginning when the currency launches, if one person has even just 20 or 30% of all Ether coins, then wouldn't that kind of create a huge disbalance from the get-go? Yeah,
that's... Exactly. That's actually one of the reasons why we wanted to have this kind of sale. Because if you look at what Ripple did, Ripple followed the just sell to venture capital strategy, which is legally easier, but it ensures that the Ripple currency units are concentrated in the hands of a few people.
Yeah, venture capitalists.
Yeah. And then the other issue is that, a lot of people ask us, well, what's the cap? What's the final supply of Ether? And we say, well, there is none. It keeps on growing by a fixed quantity every year, where that fixed quantity is roughly equal to 30% of the initial supply. So the idea there is that, the supply keeps on growing, and so it's not like there's this one fixed pie that you can gain 5% of forever. That's probably our biggest difference compared to pretty much all other existing like Bitcoin and altcoins and Ripple.
Now, Satoshi did mine many of the original coins in the beginning. Now, you have played a crucial part, obviously, in Ethereum. Would you be remunerated in any way at the launch? So, in other words, would you be assigned a certain amount of
So
coin?
Our current strategy is to say that we have... so this is still not quite finalized, but our current strategy is that we have 3 pools of Ether. So one pool is the pool that we sell. The other pool is the infinitely growing pool that's going to get mined. And the third pool is a small pool, roughly something like 30% of the Ether that we sell is something that we're going to use as an organization to pay for development long term. So
30% will be for development?
It's, well, technically 22% of the initial supply.
Okay.
That looks large, but it actually isn't that large because it keeps on going down with mining anyway. And so...
It gets diluted over time.
Yeah, it gets diluted over time. So the distribution of that basically started in December.
Yeah.
Yeah.
And you've been participating in that, I imagine.
Exactly. So, yeah, so of that particular slice, like maybe actually only about a few percent have been allocated so far. The rest of it is basically something that we'll use in the long term in order to build out the ecosystem, things like the cryptocurrency research group and so forth.
And how many coins? Is there a cutoff point, just like with Bitcoin? At a certain date, there will be the last mined Ether ever.
No.
So how's that going to work?
Yeah, it's so let's assume that we sell 10 million units of Ether.
Mm-hmm.
Then the idea is that there will be this 3 million endowment slice, of which about a quarter's pays for development so far. Then a larger amount pays for pretty much everything in the future. And the reason why it's so large basically is that we need a lot of pretty much all of our developers actually wants to be paid in Ether to some extent. So we need to have some way of satisfying that, and it actually makes more sense to just assign ourselves the Ether and get a bit less Bitcoin from purchasers rather than using the Bitcoin and buying from ourselves.
Mm-hmm.
So
that's one of the best signs that people believe in what they're doing. I think they don't want to get paid in dollars, but in Ether. That's pretty awesome.
Right. Yeah. So going back to the example, so 10 million sold, 3 million endowment, and then 3 million mined every year. So.
And is there a point where you stop the mining process, like 2021, like Bitcoin or something? I don't know.
No, it's not. So after, say, 10 years, it'll go up to 40 million. After 100 years, 310 million. After 1,000 years, 3.01 billion, and so forth.
Because that leads me to one of the most common criticism to Bitcoin, which is to say it's deflationary, right? Because it has a fixed supply from the get-go by design that cannot be changed. And it would appear that Ether would not suffer from that issue.
Right. So we're basically taking a very fine balance there. We're not really inflationary because the percentage rate at which the supply grows still tends to zero over time. Like after 1,000 years, it's 3010 million. After 1,001 years, it's 3013. So that's a 0.1% growth there. But at the same time, the supply actually keeps on growing by a fixed amount over time. Yeah, so we're basically trying to find the right balance between the two there.
Fantastic. Well, Vitalik, we've been talking for over an hour today, and it's been absolutely pleasure to discover myself and for myself more about Ethereum, and I really appreciate that. But let's say people would like to find more about you and your work. What's the best place for them to do that?
I would say first stop is definitely our website, ethereum.org. That's where we have links to our forum, our blog, our wiki. There, on wiki, we also have links to our white papers. So that describes what Ethereum is, what the motivations are. There's even a very formal protocol specification. On the blog, if you want to really get down and dirty quickly, there is a programming tutorial. It talks about how to write contracts and, the forum and the Reddit to ask questions and just sort of keep on going from there.
And if our viewers and listeners were to take a single message from our 1 hour conversation with you today, like the most important thing that you'd like them to remember, what would that be? Yeah,
I would say it really boils down to this idea that Ethereum is not a currency. It's basically, we've had this idea of decentralized consensus technology for 5 years now. Bitcoin's done really well with it, but really you can use it for so much more. And I think now is actually the time when we're starting to move away from just, let's have a decentralized currency for decentralized currency's own sake, and actually realize that there's all sorts of these different applications where you can actually do so much that you can't even do in the existing paradigm at all. So, or if you can, it's extremely inefficient. So one of the paradigms one of the examples that I always like to bring up is actually gambling. So in 2006, for example, if you wanted to make a gambling site, it would be extremely difficult. Like you would need to have a relationship with a payment processor, you would need to get a VPS, you would have set up a server, get a domain, make sure your database is secure, protect yourself against DDoS attacks and so forth. In 2012, it got a bit easier because you got Bitcoin, and with Bitcoin, you can actually do all the currency part without most of the security, without the payment processing, and so forth. In 2014, guess what the gambling sites of the future are going to look like? They're just going to be Ethereum contracts and 15 lines of code. Write them once, click compile, click push to blockchain. Push the blockchain returns to you an Ethereum address. Paste the Ethereum address onto a forum, and bam, anyone can gamble.
Well, I can see how the casinos are going to love you for that, but I'm personally one of those crazy people who believe that it's good that it's hard to get involved into gambling.
So, it's just it's an example. Yeah, it's an example, right? It's the idea is that you're taking this industry where things are very hard. It's actually very bad for consumers right now because it's very easy for gambling sites themselves to cheat, and so. And with Satoshi Dice, you have this idea of provably fair gambling, where you're actually introducing the idea that the site itself can't actually cheat because if it cheats, it becomes immediately obvious. You use cryptographic algorithms to prove that it's...
You're not using a loaded dice.
Exactly, you're not using a loaded dice. And here, you're not even choosing the dice. You're writing the dice into the contract and everyone sees your dice. And they're seeing your dice as they're getting executed.
I get that.
So the other, So, once again, it's an example, right? That's, gambling is, it's such a nice example because it's this sort of pure financial service.
It's not my favorite example. So let's do one better than that. Let's give something better. I don't think, I personally don't think we'll change the world with gambling.
I know. So a good example might be Kickstarter is also another one.
Okay.
So Kickstarter is, once again, it's a great idea. You can actually grab funding together from thousands of different people. People can start these large, well-funded projects without having to go to a VC. It's good, but at the same time, it's also inefficient. You need to deal with all the same merchant account difficulties. Kickstarter themselves takes a pretty large cut.
They take between 4 to 8%. I've dealt with them.
Yeah, and there's all the other sites take a pretty good cut too. So there's and at the same time, they're also geographically limited. If there's a lot of countries, I'm sure you can't really access them at all, right?
Actually, that's a great example because it's not true. Actually, it's much higher. I remember I ran a crowdsourced fundraising campaign myself, and actually, in the end, I lost about 12% of the value that was given to me. Because part of it was taken by Indiegogo, part of it was taken by bank fees, and part of it was lost in the conversion process in the exchange rate from US dollar into the Canadian dollar. So in the end of the day, when I did the math, it was somewhere between 12 to 14% of the value that was lost in transaction before it actually even got to me.
Yeah,
So I think that's fantastic because the transaction fees will be what, 0.5% or less?
Yeah, it's pretty close to zero, really. So here, the advantage is it's basically that actually, I remember when I released that programming tutorial that I mentioned, I released that at like 2 o'clock in the morning. I woke up again at 6 o'clock in the morning, and I found that someone had already used that tutorial and they had managed to write up a Kickstarter contract in 30 lines of code.
Wow. Yeah. And that's the kind of exponential change that we're talking about and that this show is all about. So,
exactly.
Vitalik, I have to say, I'll be watching very carefully and very closely and very curiously how Ethereum develops as a project and your future, because I believe you have a very bright future, my friend. Sure. So thank you very much for being with us today. Thank you.
Singularity.